A body is released from a point distance r from the center of Earth. If r is a radius of Earth and it is given that r is greater than r, then the velocity of body at the time of striking the Earth will be. So over here we need to consider a situation something like this. A body is released from a point distance r from the center of Earth. So we can just consider that a point is released from a point somewhere over here, which is at a distance r, small letter r, from the center. If r is a radius of Earth and this r is greater than r, that means the point is outside. So velocity of body at the time it strikes the ground is. So our aim is to find out what about the value of velocity on reaching this point. So we can just consider this is initial point and this is final point, and it is going to reach over here with a velocity that is equal to v. So we can find out the value of velocity by using conservation of energy. We can write total energy at point 1 should be equal to total energy at point 2, or total energy initial is equal to total energy final. So total energy initial, sum of kinetic plus potential. So its kinetic energy is 0 and potential energy is minus of gmm divided by, take it as mass of particle is m, and so it is g, and capital letter M is the mass of Earth. So we can write this minus of gmm divided by distance is r should be equal to total energy final at point 2. So we can write its kinetic energy is half into m into v square, and potential energy is minus of gmm by from the center of Earth. Now it is on the surface, so distance is equal to r. So we can cancel this m over here, this m over here, and this m over here. Now we can write the value of this v square in terms of other parameters. If I am taking this gmm by r towards the left side, it becomes positive. So plus gm by r minus gm by small letter r is equal to v square divided by 2. So if you are taking this gm by gm as a common, so it is 2 into g into m, and the remaining term is 1 by r minus 1 by small letter r is equal to the value of v square. So we can write this as 2 into g into m. If I am taking this r into r as LCM, so it is r minus r divided by r into r under root of this will give the value of v. So further we can rearrange, because an option you can observe that it is given in terms of small letter g, and small letter g is gm by r square. So what we'll do is we can multiply this equation with r and divided by r. So it will be in this form, that is 2 into g into m divided by r square divided by r into r minus r will be equal to the value of v. Now we can observe that this term gm by r square is equal to acceleration due to gravity on the surface, or g0. So we can write this will be equal to under root of 2 into g into r minus r divided by r will give the value of velocity.